Hello everybody. As a part of the cyber security tutorial, in this video, let us discuss about one of the error detection techniques in a computer network, which is called as checksum. So, if a computer or a device from a network is transmitting data to a computer or to a device in another network, if it has to know that the data has been transferred completely, then by using this checksum, it can always understand either the sender or the particular receiver. It will be understanding that the data is transferred completely. So for suppose if I have a computer, right, in one network like this, and I do have another computer in another network or in the same network, whatever it may be. Okay, so if I have another computer over here, okay, which we'll be calling it as a sender. This is my sender and this is the receiver. So now the data, if it transmits the data from this computer to another computer, okay, to the receiver, from the sender to the receiver. So if it has to understand that the data has been transferred successfully, so we'll be always using a checksum. So how? So in order to understand this, first of all, you have to understand that whenever a computer sends data to a particular receiver, it will be sending data in the form of packets or in the form of data bits. Okay, so data bit 1, this is my data bit 1 in the form of segments or packets, okay, or data bits we may call. So like that it will be sending the data in the form of data bits. This is my second data bit, this is my third data bit, okay, and this is my fourth data bit. So let me write the names also here so that it will be clear. So this is data bit 1, and this is data bit 2, this is my data bit 3, sorry 3, and this is the data bit 4. So these things will be happen in a transport layer. So we do have 7-layered approach in the OSI model. Okay, so all these things we'll be discussing in the subsequent classes. So in a transport layer, so the transport layer is responsible to create segments or data bits or blocks. Okay, and again it will be having a flow control, error control, all these kinds of stuff. So as a part of the error control only we are discussing this thing. Okay, so these 7 data layers, okay, so this 7-layered approach in a particular OSI model we'll be discussing in the subsequent classes. Okay, so now you have to understand this one. Okay, so this is the particular thing. So error control through the transport layer error control, this will be sending the data like this one, and it will be sending a checksum value as well, and then it will be checking. Okay, so it is the particular thing that you have to understand. So here, so what are the data bits that we do have? For suppose we do have 4 data bits. Okay, so now if the data has to be transferred to the particular receiver, okay, so the transfer is complete when we'll be saying if all the particular 4 data bits have been completely transferred over here, right? But how the sender can understand whether it has been transferred or not completely, all the 4 data bits, or else how the receiver can understand all the 4 bits that have been sent by this particular sender has got to this particular receiver or not, right? So in order to ensure that, so what the sender will be doing, the sender will be calculating a checksum. So as name suggests, checksum means what? Check plus sum. Okay, so it will be summing all the data bits over here. Whatever the data bits it do have, it will be summing all the data bits. You all know very well that computer transmits data in the form of binary digits, right? Whatever the data bits, okay, whatever the images, text will be there. Okay, so all those things will be converted into binary data, okay, binary into binary bits, okay, and then it will be sending the data. So this particular sender now what it will be doing, it will be calculating a checksum. Okay, how? By adding these 4 data bits. Okay, so it will be calculating a checksum by doing binary addition. It will be creating a checksum value. Okay, a checksum value it will be creating. So this is the checksum value, checksum. So now this particular sender, after calculating the checksum, what it will be doing, it will be sending the data, whatever the 4 bits of data, 4 blocks of data we have considered, right? With all these 4 blocks of data along with the checksum. Okay, so this is the fifth data bit we can always consider. Okay, this is the 5th data bit we can always consider. Now these 5 blocks, okay, the checksum, the 5 blocks, this particular computer one or the sender, what it will be doing, it will be sending it to the particular receiver. So along with the 4 data bits, okay, along with the 4 data bits, plus checksum. Okay, 4 data bits plus checksum, this will be sending to the particular receiver, right? So let me differentiate this one with some, so like this. So now this particular receiver, what it will be doing, it will be getting these data bits, all the 4 data bits, whatever the original data bits are there, 4 data bits, it will be getting over here, right? So after sender sending this particular data bits, it will be receiving. This is the data bit 1, this is the data bit 2, this is the data bit 3, right, and this is the data bit 4. So these are the actual 4 data bits, right? So the receiver will be receiving all the data bits that are sent by the sender. Data bit 1, and this is the data bit 2, this is the data bit 3, and data bit 4. Okay, so along with the 4 data bits, so this checksum value also it has sent, right? The sender has sent the checksum value as well. So this receiver, okay, so it also takes this checksum value. So now the responsibility of the receiver is that, again, what it has to do, whether the data has been received properly or not. So whatever the responsibility of the sender, it has done. So it has created a checksum value, and along with those 4 data bits, it has sent the checksum value to the receiver. So this receiver, now what does it has to do? It has to take this checksum value sent by the sender. Okay, so this is the checksum value. This is another data bit, right? Where we are calling this as checksum. So this checksum value, now it is the responsibility of the receiver to add to these 4 data bits. Okay, so now 5 data bits are there. Okay, if you consider checksum value as a data bit also, now 5 data bits are there. Now it has to add all these things. So if at all it gets all ones. Okay, so for example, in each block we do have 8 bits for example, consider. So it should be having all the 8 bits are ones only. You should be having all the 8 bits as ones only. That means the output 1 1 1 1 1 1 1 1. Okay, you should be getting, because we have considered what, 8 bits in a particular block. Okay, so that is the particular thing. You should get output as all ones only. Okay, then it will be considering that it has got the correct all the data bits, okay, with all the packets correctly. Okay, so that is the particular process. Okay, so now let us see how to do this one. Okay, how to do this practically. Okay, now let us see. So if I go over here, yeah, so what he's saying over here, so we have to follow some steps. Well, I have explained simply over here. Okay, so this is the process, but we have to follow some steps in order to do this one. So from the sender side, if you are considering, okay, to create the checksum, how we have to create, we have to break the original message into k number of blocks with n bits in each block. Okay, that's what you have to do first of all. So as I have specified, so each block, okay, so if you consider that the data is there, okay, some 32-bit data is there. Okay, I'm going to take that 32-bit data only. So 32-bit data is there. So if that 32-bit data, what we have to do, we have to divide into, if we divide into 8 bits, basically if we divide into 8 bits, how many blocks will be getting? 4 blocks. Okay, 4 blocks will be getting, so each block with 8 bits. So that is like that we have to divide. Okay, so for example, say let me take this one only. So I do have this 32-bit data actually. Okay, so this is the 32-bit binary digits we do have. So now according to the first step, what I have to do, this sender has to do what it has to do, break the original message into k number of blocks with n bits in each block. So I have to divide into k number of blocks first of all. So because this is a 32-bit data, I will be dividing into 8 bits. Okay, so from here if you calculate, okay, 1 1 2 3 4 5 6 7 8. Okay, so till here this is a block, okay, which is having 8 bits in this particular block. And again 1 2 3 4 5 6 7 8, this is the second block. And again here also we do have 8 bits in the second block as well. And 1 2 3 4 5 6 7 8, this is the third block. And again we do have 8 bits in this block also. 1 2 3 4 5 6 7 8, this is the fourth block where we do have 8 bits. So according to the first step, what we have done, break the original message into k number of blocks with 8 number of bits. K number of blocks, we do have 4 blocks. Okay, here k means 4, we do have 4 blocks with n number of bits. How many bits we do have? 8 bits we do have. Okay, so we have done the first step. So second step, what we have to do, we have to sum all the k data blocks. Okay, we have to sum all the k data blocks. So in our case 4 data blocks are there, we have to sum all those 4 data blocks. This is the second step that we have to do. And third step, right, once after adding, if you do have any carry, okay, in the binary addition, if you do have any carry, then again that carry also we have to add to the actual result. Okay, so that is the third step. The carry also we have to add to the actual result, and that is the third step. And the fourth step is that whatever the final result is there, we have to do ones complement for that one. That means either zeros, if zeros are there we have to convert into 1, and ones, if ones are there we have to convert into 0. So that is the thing that we have to do. So 4 things we have to do basically. One is that, as we have done, okay, we have to we have to divide the data whatever that is transmitting into k number of blocks. Here we have divided into 4 number of blocks with n bits each, right, with n bits each he is saying. So 8 bits each we have divided. Okay, so that is the first step. Second step, we have to add now. So how we can add? Okay, so let me put senders addition. Okay, so here let me take a table. Okay, see, because we do have n bits and 4 data blocks and n bits, right? 1 2 3 4 5 6 7 8, 1 2 3 4, and for carry 1 row I want, and again even if I get carry 1 row I want, and result 1 row I want. So these are all the rows I have taken. Okay, so what I'll be doing, I will be putting all these things in the particular rows over here. Okay, so starting from this one, so I do have 1 0 0 1 1 0 0 1 as the first block, right? And this is my second block where I'll be having 1 0 0 4 zeros in fact, and again 1 0 0, right? 1 4 zeros 1 double 0, yes, right? So this is the third block. Okay, so 0 0 1 0 0 1 0 0. So 0 0 1 0 0 1 0 0. This is third block, and fourth block, this is the fourth block. This one is the fourth block for me, and 3 ones 1 1 1, and 3 zeros again 1 1 1 and 1 and 0. Okay, so now I have to perform a binary addition. So whenever I am performing a binary addition, if we add 1 with 0, the result is 1 only. So in the first bit across all the blocks, block 1, block 2, block 3, block 4. Okay, so in block 1 we do have first bit as 1, and in all the other blocks we do have 0. Okay, so whenever I add 1 with 0, I'll be having the result as 1 only, that in the binary addition. Okay, similar is the case over here, 0 0 0 1. Here also it is 1. Okay, and all the blocks, in the first three blocks the second bit is 0, and from the fourth block the second bit is 1. If I add all these things, I'll be getting 1 as the result. And now if you see over here, in the third bit, for second and third blocks we do have 1. Okay, so whenever I add two ones, right, the output is 1 0. The output is 1 0. The result I'll be putting as 0 over here, and I'll be taking the carry over here. Okay, and here if you see the fourth bit across all the blocks. Okay, so in fact in second, third and fourth blocks we do have 0. In the first block we do have 1, but if I add this one, I'll be having 1, but I do have carry also over here. So if I add 1 and 1, again the result is 1 0. I'll be putting 0 in the result, and I'll be taking the carry over here. Okay, here also the same case in the first block. Okay, so the fifth bit is 1, and in all the other blocks it is 0. Because I do have a carry, I have to add 1 plus 1, 1 and 1, and if I add 1 and 1, the binary addition will be 1 0. I'll putting the result as 0, and I'll be taking the carry 1, right? So now if you see over here in the sixth bit, okay, for the first and second blocks we do have 0, and third and fourth blocks we do have 1. If I add simply this one, the result will be 1 0, but I do have carry as well. I do have 3 ones over here. So whenever I add 3 ones, okay, in the binary addition, I'll be having the output as 1 1. So in the result part, I'll be putting as 1, and I'll be taking the carry 1 over here again. And here if you see over here in the seventh bit, only the fourth block is having 1, and all the other blocks are 0. If I add this, only 1 I'll be getting the result, but I do have a carry here also. So 1 and 1, the output is 1 0. I'll be putting 0 as the result, and I'll be taking the carry 1 over here. Okay, so now if you see over here, I do have 4 ones. Okay, so in all the blocks apart from the second block, okay, eighth digit is eighth bit is ones, all are ones, but apart from that I do have a carry as well. That's why I do have 4 ones. For 4 ones in the binary addition, okay, we will be having 100 is the output. 100 is the output actually, but what I'll be doing, I will be putting in the result 0 only, and I'll be taking 1 and 0. Whatever the 1 0 is there before this one, before the last 0, this 1 0 I'll be taking it as carry. And what I'll be doing as a third step, right, what we have thought as a third step, if at all we get a carry, we have to add that carry as well. Add the carry to the sum if any. So 1 0 I have got as a carry, right? I will be adding this one as the to the result. This one to the result 1 0. Okay. So again I have to take a row over here. So now I have to add only these 2 rows. Okay. Only this is the result actually. This row is the result. And because we do have a carry, this row is the result. And because we do have a carry, I am adding this carry as well. We need not consider all the other things. Only this one and this one. Okay, so 1 0. 1 0 is what? 1 only. And 1 1 is what? 1 0. In the result I will be putting 0, and here the carry I will be taking 1, and 0 and 1 1. 0 and 1 1, and there are no other things over here. I can simply put whatever it is over there: 0 0 1 0 0, right? So this is the result that I have got, but still there is a one step. What we have to do, we have to do one's complement over here. We have to do one's complement to the sum whatever we have got. Okay, so that means let me add another row as well. So one's complement, so if I come from here, so one's complement of 1 is 0, 0 is 1, 1 is 0, 0 is 1, here also 1, 0 1 1, right? So this is my checksum. So once after doing this one's complement after the result whatever we have got, okay, this is my checksum. Okay, so how we have got this one? So we have divided our entire data into 4 data blocks, each with 8 bits. So we have added all these 8 bits. Okay, so and again this is the particular result we have got. Okay, once after adding the 4 blocks with each of 8 data bit with each of 8 bits. Okay, so this is the result we have got, and because we have got a carry, again we have added the carry, so the final result is this one. Okay, and to this one what we have done, we have complemented, we have done one complement. Okay, once complement we have done, so that it is the checksum value, actual checksum value. Okay, so now as we have discussed this checksum value along with this 4 data bits, see this is also a block, this is also a 8-bit block, correct or not? Okay, so this 8-bit block will be sent along with these 4 data bits. What are the 4 data bits we have seen? These 4 data bits, this block is also be sent as a checksum. So now it is the receiver's responsibility. So now what the receiver should do actually? So from the receiver side, sum all the k data blocks along with the checksum value. What are the data blocks it has sent? Now in our case, how many data blocks? 4 data blocks. Okay, so these 4 data blocks, first 4 data blocks are there, right? Actual data blocks, these are the particular things. So these along with those 4 data blocks, what are the checksum value we have got over here? Okay, this checksum value we have to add along with those 4 data blocks. Okay, so and again if at all we get any carry, again that carry to the result we have to add. If the result in each bit, okay, in each bit if we get one exactly 1 as each bit, okay, then it is correct data transfer. Okay, then it is correct data transfer, then it accepts that the data has been transferred, otherwise it simply rejects. Okay, that is the thing that it will be doing. So now what we have to do, we have to do the receiver's addition. Now as we have done the sender's addition, we have to do the receiver's addition. Okay, so what I'll be doing, I'll be taking again a table, okay, with 8 rows, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. Okay, so these many rows I'll be taking. Let me take, it has been divided into next page. Okay, so let me take in the fresh page itself. Okay, so these are actually our 4 data blocks, correct? Right, so these are all the these are the 4 data blocks. So let me copy all these things simply. Okay, I'll copy this and I'll paste it over here. From here I'll be leaving the first row for my carry. If at all I get any carry, I'll be leaving for that one. So in these 4 rows I'll be copying the 4 data blocks, whatever the data blocks, 4 data blocks are there, I have copied. So along with that, what I have to do with the actual 4 data blocks, I have to add the checksum value as well, which has been sent by the sender. This is the checksum value sent by the sender, right? So now I am copying this one and I will be placing along with the 4 data blocks over here, and I'll be adding this one. Okay, so now if I add, see what would we have? 1 and all zeros, so the result is 1. So here what would we have? 3 zeros and 2 ones. 2 ones are there, the result is what? If we have 2 ones in binary addition, we have 1 0 as the result. 0 I'll be putting and I'll be taking 1 as the carry. And here if you see 3 ones are there in this particular column, right? This is the third bit. Okay, for the third bit, okay, so we have 3 ones are there, so the result is 1 1. So I'll be putting 1 over here and I'll be taking 1 as carry as well. Here also Okay, 3 ones are there along with this carry, otherwise 2 ones are there, but with this carry it has become 3 ones, so the result is 1 1 only again, and I am putting 1 over here in the result, and I am taking carry as 1 over here. And again, if you see here also 3 ones are there with this particular carry, and again the result is 1, and I'll be taking the carry as 1 over here. And again here also 3 ones are there, 2 actually from the data blocks, okay, 1 with the carry, so 3 ones, 1 1 is the result, so 1 I'll be putting over here and 1 I'll be taking as the carry. And here again if you see 3 ones are there along with the carry it has become 3 ones, so here also the output is 1 1, in the result I'll be putting 1 and I'll be taking the carry 1 over here. So now if you see over here, how many ones will you have? 1 2 3 4 5 ones are there in this particular column. Okay, so in a binary addition, if you do have 5 ones, it is 101. It is 101. If you have if you have 4 ones, okay, in a binary addition, what is the value? It is 100. If you have 3 ones, it is 1 1. The result is 1 1. If you add 2 ones in the binary addition, the result is 1 0. Okay, so 101 we have got. So that means what? I'll be putting only 1 in the result and I'll be taking 1 0 as the carry. Okay, so what this is the result. I'll be taking 1 0 as the carry over here. What I have to do if I get a carry? I have to add again this one. Okay, this is not my result then. Again I have to add this one, and whatever the value I will be getting, right, that is the actual carry. So now these two things I'll be adding 1 0 as 1. Okay, 0 1 1 only according to the binary addition, and all the other remains, all the other things remains intact. Okay, so 1 only everywhere in each bit. Okay, so according to the particular thing, so what he is saying over here, we should get a result as 1 in all the bits, right? In the particular block, in all the bits as 1 only we should get the result. Have we got 1 or not over here? See, in each and every bit we have got 1 only. That means whatever the data that has been transmitted is correct. Okay, so in this way the checksum value will be calculated. So this is important, okay, very important in interviews and all. So as I have specified, this will be done in the transport layer in a particular in the particular 7-layered approach of the OSI model. Okay, so these 7-layered approach are very very important. Okay, and we'll be discussing in the subsequent videos. Okay, so this is all in this video, and again we'll be meeting another topic. Until then, have a great time. Bye bye.